Number 10 on the test got a lot of requests for video. So this is a mixtures problem. It's a pretty classic problem. And sometimes it's people have a hard time seeing the two equations that are embedded in one of these. So the question goes, bronze, which costs $7.05 per kilogram, is made by combining copper, which costs $6.20 per kilogram, with tin, which costs $8.70 per kilogram. Find the number of kilograms of copper and tin required to make 50 kilograms of bronze. All right, so we have two equations here. The first equation I'm going to deal with is the one that shows up second in the problem. Find the number of kilograms required to make 50 kilograms of bronze. So we know there's a total number of kilograms that we're going to have, which is going to be 50 kilograms. And some of that is going to be copper, and some of it is going to be tin. So I'm going to say C equals copper, and T equals tin. Now, that means I have some number of kilograms of copper plus some number of kilograms of tin, which will equal 50 kilograms of bronze. So there I have one equation. Now the second equation, part of it will be very obvious. There's a price per kilogram for copper, so 620 times copper, and a price per kilogram for tin, so that's two rates here. So two rates, that'll lead us to very likely a standard form equation, and that's going to equal something. Now, a lot of people, when they tried this one, they tried to make this equal $7.05, but that's not $7.05. That's how much 1 kilogram of bronze costs. We want to know the total price of all the kilograms of bronze, which means we're going to have to multiply $7.05 times 50 kilograms. Okay, so now we have two equations we can work with. Now, when we do this, we going to have to sort this out. I'm going to drop all the dollar signs, so that becomes 6.2c plus 8.7t equals, and then 705 times 50 is going to be 352.5. Now we have another equation. We have an equation in terms of price. So $6.20 times the copper plus $8.70 times the amount of kilograms of tin will get us the total number of total cost of the bronze, which is $7.05 for every single one of those 50 kilograms. All right, I'm going to do one more step before I start trying to solve this system. I'm going to get rid of these pesky decimals. And the way I'm going to do that is I'm going to multiply the entire thing, everything, by 10. And by multiplying everything by 10, I move my decimal places over one place, and I get 62c plus 87t equals 3,525. Cool. Now, this is a great example of a problem where I would actually do substitution. I know you probably never thought I'd see me say this, but I am going to do that. So I'm going to copy this equation here and see what we can make of it. So this means C plus T equals 50, then C equals 50 minus T, and T equals 50 minus C. You can just rearrange those two equations by subtracting T from both sides or subtracting C from both sides. So now I'm going to take one of these and I'm going to put them into replace either X or replace either C or T with it. I'm going to go ahead and replace C because I feel like multiplying 62 is going to be a little easier to deal with than multiplying 87. I'm going to take this equation, and I'm going to replace C with 50 minus T. When I do that, I will have an equation in terms of one variable. Okay, now we got to simplify it, which is of course easier said than done. But 62 times 50 is going to be 3,100. And that's going to be minus 62t, and that's going to be plus 87t, and that's still equaling 3,525. So now I'm going to combine like terms. I've got 3,100 and negative 62t and positive 87t is going to be 25t, which is looking like a nicer number to work with. And that still equals 3,525. I'm going to subtract 3,100 from both sides. And I've got 25t equals 425. All right. I'm going to divide both sides by 25. And I've got now t by itself. And 425, if I have $4.25 in quarters, I have 17 quarters. So t equals 17. And now I can go in and figure out what c equals. If t equals 17, then 50 minus 17 equals 33. So I have 33 kilograms of copper and 17 kilograms of tin. At this point, you should try some of the mixtures problems that I gave you in 4.3.